Hello dear students, I welcome you again. This is the lecture number 14 on linear differential equations with constant coefficients that we are doing presently, and in that we have taken the homogeneous linear equations, which are also known as Cauchy Euler equations. Cauchy Euler equations. I want to today discuss with you, share with you the applications on this so that you will come to know how we solve, how we recognize. Actually, first you have to recognize this homogeneous linear equations, which is reducible. It is an equation which is reducible to the linear differential equation with constant coefficients. It is one is this Cauchy Euler equation, and we have one more there. It is known as this Legender's second order differential or any order differential equation, which can be reduced to this linear differential equation with constant coefficients. Let us come have the solution of these. I have quoted here some examples. These are the best examples taken from different books, engineering mathematics books, your textbooks, which is a part of your syllabus. Let us have the solution of these. Solutions we shall discuss. Solution. The first equation is, we have to solve. It is x cube d cube or d3y dx cube plus twice x square d2y dx square plus 2y is equal to 10 times x plus 1 by x. This is our differential equation, which is of course homogeneous. It is a homogeneous linear differential equation, or you may say it is Cauchy Euler equation. How you recognize it, how you come to know? Here you have the independent variable x cube, the order of the derivative 3, x square, order of the derivative 2. Here you have the last term 2y, and last time in lecture number 13 I have discussed this. It is solution, how we solve this, method of solution. So method of solution is, we put x is equal to e raised power z, which gives by applying log, z is equal to log of x, and you have dz by dx here 1 by x. Then you will write now directly. You can write directly because you have the solutions of this. You can write now directly. Now by this substitution, by above substitution, this suitable substitution, we have x dy by dx is simply dy, where your d will be d by dz. Remember this, it is d by dz. How it is? Please go to lecture number 13. If you have any problem here, how we write this, go to lecture number 13, see there, solve there. This I have given you the method how to find out this x dy by dx as dy. Then you have x square d2y by dx square. What is this? It is d into d minus 1 into y. D minus 1 into y, d is same this. And you have, because you have x cube here, x cube d3y dx cube will be d times d minus 1 into d minus 2 into y. Now using all these in first, this implies equation first reduces to, it is actually a transformation. It will get reduced to this. I replace this x cube d3y by dx cube by this. This is your d minus 1. This is d minus 2y. Then this is 2 constant will be here 2. What is x square? It is d into d minus 1y. Then plus 2y. You don't have x dy by dx here, okay? If it is not, we write only 2y. It is equal to 10. What is this x now? Look here. Your x is e raised power z. Write e raised power z. What is 1 by x? That will be actually 1 by e raised power z. Now simplify this. This implies it is d times d square. When you multiply this, minus 2d minus 2d minus d, it is minus 3d plus 2 into y. Then plus 2, it is d square minus d into y plus 2y. We can write this as 10 e raised power z plus e raised power minus z. Let us come now here. I will rub it because I have to solve this now. Well, this gives me, this is now this implies you have d cube minus 3d square plus 2d I will take y outside, plus 2d square minus 2d square minus 2d plus 2 into y is equal to 10 times e raised power z e raised power minus z. This is your d cube minus 3d square plus 2d square. It is your minus d square. Then you have plus 2d minus 2d. It goes plus 2 into y is equal to 10 e raised power z plus e raised power minus z. We will just look again. It is d cube minus 3d square plus 2d square, mean is minus d square plus 2d minus 2d goes plus 2. Well, this is equation number second, a reduced equation where we have x e raised power z. Finally, we have to replace this e raised power z by x. Well, you have here as usual what is auxiliary equation. It is d cube minus d square plus 2 is equal to 0. It is your auxiliary equation. It is a cubic. You can solve it by this inspection. What is the inspection here? If I put d is equal to minus 1, yes, d minus 1 satisfies. D is equal to minus 1. What is this? It is minus 1 plus 2 is equal to 0. 0 is, yes. D is equal to minus 1 satisfies equation. I have already told you in case of cubic, you make the inspection, by this inspection, put d minus 1 plus 1, 2 minus 2, then one of the value satisfies. Otherwise, you have to take another method known as Cauchy's rule. Now we apply synthetic division. Okay? Synthetic division. I have already explained you the synthetic division in starting lectures. How you apply synthetic division? Write all the coefficients. Coefficient of d cube, it is 1. Coefficient of d square, it is minus 1. You don't have d. You have to write down the coefficient. It is 0. Coefficient constant is 2. It is very important. The missing term whose coefficient is 0. Then apply by minus 1. Write 1 here. 1 into minus 1, it is minus 1. This is minus 2. Minus 2 into this, it is your 2. Add this, it is 2. 2 into minus, it is minus 2. This is 0. This also verifies that it is the root. D is equal to minus 1 is the root. So what is the reduced equation? A reduced equation is now d square minus 2d plus 2 equal to 0. It is d is equal to 2 plus minus under root of 4 minus, it is 4 minus 8 by 2. This is equal to 2 plus minus minus 4 it is actually 2 iota 2 by 2. I will rub it, I don't need it. Then you have d is minus 1, it is 1 plus minus iota. Corresponding to this, what is complementary function? It is c1 e raised power minus. Be cautious, our d is d by dz. You should be very cautious here and don't write x. It is because my d is here d by dz. So e raised power minus z plus This is your complex number, e raised power real part 1 into z. This is c2 cos of imaginary part, iota ka coefficient 1, it is cos z plus c3 sin z. So my complementary function is at this top point e raised power minus z plus c1, it has 3 roots, yes, plus e raised to power z into c2 cos z plus c3 sin z. Let us underline this. This is your complementary function. Now you go for particular integral. How you find out particular integral? Now we find it is particular integral. What is particular integral? Our particular integral will be 10 times e raised power z plus e raised power minus z by, oh, what was equation number second? I have rubbed it. How I find it now? It was d cube minus 2d plus 2. No, it was d cube minus d square plus 2 is equal to 0. I will just, because I have rubbed the equation, it is d cube minus d square plus 2, d minus 1, yes. What is the, then you have plus minus iota. Okay, it is this. It is d cube minus d square plus 2. Equation number second. Then it is particular integral is 10 times e raised power z by d cube minus d square plus 2, then plus e raised power minus z by d cube minus d square plus 2. It is the exponential. How you do? The coefficient of z is here 1, replace d by this. It is 1 minus 1 plus 2. Yes, it is defined. It is defined. Here you have to put d minus. It is minus 1, 1 plus 2. It is not defined. Here we have to apply the failure rule. You know, it is particular integral 1. It is 10 times e raised power z. Coefficient of z in this, it is 1 cube minus 1 square plus 2. It is okay. It is well defined. Plus, but here when we put here minus 1, it is minus 1 cube. Then it is 1. It is minus 1 plus 2. It is undefined here. So what we do is we write z here out, e raised power minus z, differential of d cube minus d square plus 2 with respect to d. Do you remember this? This is the previous method where failure case, when e raised power ax f of d fails, then we differentiate denominator with respect to d, take z out. This is your 10 e raised power z by 2 plus z e raised power minus z by derivative of this is 3 d square minus 2d. 3d square minus 2d. Well, this is your particular integral is 10 times e raised power z by 2 plus z is out. Now use here the quotient, this exponential rule. It is e raised power minus z in the exponent power of z, quotient of z is minus 1. It is 3 times minus 1 square minus 2 into minus 1. This gives you particular integral is 10 times e raised power z by 2. Then it is plus z e raised power minus z by, it is 1. This is minus minus plus 2. 3 plus 2, it is 5. 3 plus 2, it is 5. So you can write your particular integral is, it is 5 times e raised to power z plus 2z e raised power minus z. This is your particular integral. Be cautious how we write down the solution now. How we write down it is solution. Look for the solution. Well, what is now solution? Now required solution is y is equal to complementary function plus particular integral. It is y equal to your complementary function is c1 e raised power minus z plus e raised to power z, c2 cos z plus c3 sin z, then particular integral is plus 5 e raised power z plus 2z e raised power minus z. Now look here, I will make it short now. We have put x is equal to e raised power z, means where you have z, instead of z you will write log x. You will replace z by log x, and e raised power z by x, e raised power minus z by x raised power minus 1. So solution is y equal to c1. What is e raised power minus z? Look here, x is e raised power z. What is e raised power it is minus, it is x raised power minus 1 plus e raised power z, it is simply x. c2 cos of z, what is z? Log x, it is log of x, plus c3 sin of log x, this is the complementary part, plus 5 e raised power z means 5x plus twice what is z, it is log x, it is x raised power minus 1 log x, because z is our log x, e raised power minus z means x raised power minus 1. This is the complete solution of this differential equation, which was homogeneous linear differential equation or Cauchy Euler differential equation. In this way I have solved this one. Let me take another differential equation. Let us come here now to solve solution of second one. This is x square d3y dx cube plus minus 4x d2y dx square plus 6 dy by dx is equal to 4. Now this seems to be not homogeneous, but if we do not solve it by homogeneous method, but it is reducible to homogeneous. How? If I multiply third by x, this becomes x cube, this becomes x square d2x, this becomes x dy by dx, this is 4x. So by multiplying x we can make it homogeneous, this Cauchy Euler differential equation. Multiply both sides by x. You know that x here is not 0. You are not multiplied by a 0 number. X, if x is 0, then this whole becomes 0. Is x is equal to 0 is not the solution. So we multiply both sides by x. This becomes x cube d3y dx cube. This is your minus 4x square d2y dx square, then plus 6x dy by dx is equal to 4x. Now this is homogeneous linear differential equation or Cauchy Euler differential equation. How you solve it? You make the substitution now. You put suitable substitution, x is equal to e raised power z. When you put x is equal to e raised power z, what you get? This gives you x dy by dx is your dy. This gives x square d2y by dx square is, you have to write it in solutions, you have to write it directly, but in the term we have derived there. It is d into d minus 1 into y. You have also x you have not x, yes, you have x cube. This is x cube d3y dx cube is d into d minus 1 d minus 2 into y. Therefore, by this method, this substitution, equation number second gives. So second equation implies now by this substitution, it gives you d into, when we use here, d minus 1 d minus 2y minus 4 times d into d minus 1 y plus 6 dy is equal to 4. What is our x now? E raised power z. So when you multiply it is d into d square minus 3d plus 2, then minus 4d square minus 4d plus 6d y is 4 e raised power z. Now we have to simplify this one. So on simplification, this will be your d cube minus 3d square plus 2d minus 4d square plus 4d plus 6d y is 4 e raised power z. Well, this is d cube minus 7d square plus 12d into y is 4 e raised power z. This is third equation. Let us write here, it is auxiliary equation. I will write here what is auxiliary equation. It is d cube minus 7d square plus 12d is equal to 0. You can take d common. D square minus 7d plus 12 is equal to 0. One root is d0. Other two roots will be d square minus 7d plus 12 is equal to 0. That is d is equal to 7 plus minus under root of 49 minus 48 by 2. It is d is equal to 7 plus minus 1 by 2. So d is 4 and 3. Therefore you have here d is one value is 0, 3, 4. So what is complementary function corresponding to this? It is c1 e raised power 0 z plus c2 e raised to power 3 z plus c3 e raised power 4 z. Be cautious because our d is here, our d is here, d by dz, not d by dx. So that complementary function is, it is c1 plus c2 e raised power 3z plus c3 e raised power 4z. Now what is particular integral? Particular integral will be 4 e raised power z by this d cube minus 7d square plus 12d. Now you have to replace the coefficient of z here 1. It is 4 e raised power z by 1 minus 7 plus 12 because d is replaced by coefficient of z in the exponent. It is 13 minus 7. It is 4 e raised power z by 6. This gives 2 by 3 e raised power z. So what is complete solution? Complete solution is y equal to complementary function plus particular integral. What is that? Your complementary function is there, c1 plus C2 e raised power 3z plus C3 e raised power 4z, then plus 2 by 3 e raised power z. Look here, what is your substitution? Your substitution was, you remember, your substitution was, what was that? X is equal to e raised power z. Okay, so you can write y solution is C1 plus C2 e raised power 3z means x cube, C3 e raised power 4z means x4 because we have to raise 3 here, then plus 2 by 3 e raised power z means simply x. This is the solution of this differential equation. I have also given you one example here where you need here x to make this homogeneous. You need here x to make this homogeneous. But if it is here x square, then we have some other method. We do not say it is a homogeneous or Euler. This is what is known as Cauchy Euler. It was reducible to Cauchy Euler differential equation. This is done. Let us come to next one. Let us now take solution of third equation. It is x cube d3y dx cube plus 3x square d2y dx square plus x dy by dx plus 8y is equal to 65 cos of log x. X cube d3 x square d2y dx x dt is a homogeneous linear differential equation. So what we do is we make the substitution, put suitable substitution, x is equal to e raised power z, which gives us x dy by dx is dy, x square d2y by dx square is 2 factors are involved, d into d minus 1y, x cube 3 factors are involved. In this case 3 factors are involved. One is d, then d minus 1, then d minus 2 into y. This is this. So equation number 1 implies what? This is your d, d minus 1, d minus 2 plus this is 3 d into x square, d minus 1, then plus this is simply d, I will take y out into y is equal to 65 cos of, yes, look here, cos of log x. What will be log x here? Our substitution is x is equal to e raised power z. When we apply log on both sides, what is log of x? It is z. It is cos of z. Because when you have x is equal to e raised power z, log x will be z simply. So here log cos of log x means cos of z. Let us simplify this now. This will be d, d square minus 3d plus 2, this is your plus 3 d square minus 3d plus d is dy plus d is dy plus 8 y is 65 cos z. Simplify this, d cube 3d square plus 2d, d cube minus 3d square plus 2d plus 3d square minus 3d plus d minus 2d plus 8y 65 cos of z. Now what does this give you? This and this will not survive, this and this will not survive. It is d cube plus 8 into y is 65 cos of z. Well, how you solve it now? So our differential equation gets reduced to it is now d cube plus 8 y is 65 cos z. Second, what is auxiliary equation? It is d cube plus 8 equal to 0. How you solve it? You can have it as factors. You have it as factors. This is actually d cube plus 2 cube is equal to 0. A cube plus b cube. A plus b into a square minus ab, that is minus 2d plus 2 square, it is 4 is equal to 0. You have a plus b into a square minus ab plus b square. Yes, this gives one factor, one root. D plus 2 is equal to 0. It is d equal to minus 2. Then you have d square minus 2d plus 4 is 0. This gives d is equal to 2 plus minus under root of 4 minus 16 by 2. This is your 2 plus minus under root of minus 12, that is iota root 12 by 2. It is d is equal to 2 plus minus 2 iota root 3, because it is 4 into 3 by 2, 2 goes. D is 1 plus minus iota root 3. So accordingly I will rub it. So my roots are d is minus 2. I have simplified it. 1 is 1 plus iota root 3. What is the complementary function? It is c1 e raised power minus 2z. It is 2 here. It is complex here. It is e raised to power real part 1 into z. Then c2 cos of root 3 coefficient of iota root 3 z plus c3 sine of root 3, because your independent variable is here z. This is your complementary function. What about particular integral now? Now particular integral is 65 cos z by d cube plus 8. Be cautious here how we go to find out it. We can write it 65 cos z. I will write this d square into d plus 8. Why d square? Because when we have the right side cos or sine, we replace d square by minus a square. When it is cos ax or sine x, what is your a? It is 1 square. So this is your 65 cos z. I will write it minus 1 square coefficient of z in the angle. D is here plus 8. Therefore your particular integral comes out to be 65 cos z by, it is 8 minus d. It is 8 minus d, but I need here d square. For that what I have to do? I will rationalize here. I will write here 8 plus d by 8 plus d. Rationalize by this 8 minus d. This comes out to be, particular integral is 65 cos z into 8 plus d by 8 square minus d square. This is equal to 65 cos z by 8 square, it is here 8 plus d, be cautious here, 8 square minus 1 square. Which 1 square it is? It is this cos a z, d square is replaced by minus a square. It is cos 1 z, d square replaces minus 1, not minus 1 whole square, minus separate 1 cos square. So it is this. This comes out to be 65 cos z by 8 plus d by 64 plus 1. That is 65. This goes. Therefore, you have now. Shall I rub it? If you need it, take the screenshot. If you need it, take the screenshot. I will rub it. So, particular integral is now cos z into 8 plus d. What is this? It is equal to 8 cos z plus d of cos z. 8 cos z plus d of cos z, derivative of cos z. This is particular integral is 8 cos z plus cos z, derivative of cos z minus sin z. This is your particular integral. So what is the solution? So solution of this differential equation is, let me write the solution here. So complete solution is y is equal to complementary function plus particular integral. It is y is equal to, this is your complementary function, c1 e raised power minus 2z plus e raised to power z, c2 cos of root 3z plus c3 sine of root 3z, then plus particular integral is 8 cos z minus sin z. Now in this, what you have to use now? You have to use here your x is e raised to power z by substitution. Your x is e raised to power z, where you have e raised to power z, use x, and z is your log x. You use it here, you will get the solution. So complete solution is it is this, y equal to c1 e raised power minus 2z, that is raised here minus 2, c1 x raised power minus 2 here, then plus e raised to power z means x times e raised power z is x, c2 cos of root 3, what is your z, log x, then plus c3 sine of root 3 log x, root 3 log x, then plus 8 cos of z means log x minus sine of log x. This is the solution of this problem also. Now you have one more problem, one or two problems. We will do one more lecture on this Cauchy Euler equation or homogeneous differential equations, so that these are all differential equations you have seen. By a suitable substitution, x is equal to e raised power z, we can reduce them to the linear differential equation with constant coefficients. So we also do these types in this case, which are reducible to linear. Our actually our this topic is linear differential equations with constant coefficients. We are also dealing or taking into this here those differential equations which are reducible to linear differential equations with constant coefficients. One of them is the Cauchy Euler equation, and second will be what is known as Legender's differential equation. Thank you very much. We will see you next. Thank you.